Hello, folks. I'm sure you getting tired of seeing all these different videos, but once again, this topic is a little bit difficult to be able to show, and I wanted to make sure that we saw a couple of different visual aspects of this, in addition to just the math and the notes on it. So, anyway, let's get right to it. I've been trying to get this simulation to work. I've opened it in Firefox this time instead of Chrome. Hopefully, it won't make my computer freeze like it has the last 5 times I've done this. So, anyway, here we go. So, we've talked about single slit, double slit diffraction over the last couple of videos. And I think the FET simulation here that I'm looking at does a very good job of showing this. We have a or a single slit here. The slit width is about 500 nanometers, and I have green light going through it. So that means green light is around 500 nanometers. So the slit width opening is approximately the wavelength of the light that's incident upon it. What we'll notice here is that we pretty much have circular waves propagating. We just have this intensity distribution on the screen, but it's a fairly even distribution of intensity as the circular wave propagates from the slit to the actual screen. As we increase the slit width, though, we can see that the intensity at the middle part of the screen increases. But what I want to make sure we understand, we talked about Huygens principle a little bit, and notice that due to the interference patterns that we get this planar wavefront here. But notice what's starting to form over here. We get this very, very small secondary spike, and this reduces down to almost 0 right here. So we almost have a dark fringe here, and then another small maxima, which this would be the first bright fringe past it. Remember, with single slits, everything's in halves, so it's a little different. This technically is M1 because of the way the equation uses the full length of the slit instead of the distance between the slits. But anyway, we'll go through all of that stuff a little bit more detail later. But this is your first maxima beyond your main central maxima. As we increase this a little bit more, you'll notice that this starts to increase as well. The one thing I don't like about this simulation is this does not reduce down to 0 at this point. I would expect our graphs to reduce down right here to 0. Okay, so anyway, that's single slit. Let's change this to the 2-slit apparatus. Oh, they got that really small there. Give me a second here. I'm going to get this around 500 for the distance between them. Okay, so notice with the double slit, we have our central maxima, but then we have our first order minimum and then our first order maximum on either side of this. So due to the circular wave nature, so I've got the slit width about equal to a wavelength, and I have the separation distance here. And once again, due to the visuals, this, we can only draw this so well. I don't think we're going to be able to draw and sketch out a slit separation of 1500 nanometers. So we always overemphasize them when we're drawing them on paper. Okay, so as I decrease the separation, notice what happens is it spreads the interference pattern out. Okay, so decreasing the slit distance actually spreads the pattern out, and if we increase the distance between the slits, now we get the pattern that forms very, very, very close together. Okay, and you can see all of the different interference patterns that are forming here due to the overlapping nature of those waves. So that's really what I wanted to show you guys. Oh, I was going to show you one other thing here real quick. Sorry. Let's go to this. I'm going to go ahead. So on the notes, I was talking about having a circular opening. So notice that this is our opening here in the middle of the screen. And then we have our other screen back behind here. Notice the interference patterns that show up. We have a bright spot, and then we have these concentric rings that form. Okay. If we change this to a square opening instead, we get all of these really cool interference patterns that show up. If we get these dots, you can see all sorts of things that show up there. It's really pretty cool in order to see some of the differences in what we have here. I don't think this simulation, unfortunately, is going to let me put a dot there instead to reverse it, but that's okay. You should get the picture of that. That's it. That's all I wanted to cover on this video.